Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Um, Today's puzzle is called Counting Carefully by Skojo. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and 3x3 box. We have counting circles, where a digit in a circle indicates how many times that digit appears in a circle. So, for example, if there were, say, a 5 here, that means in the puzzle there would have to be 5 total 5s in circles. So, something like this would be valid because we have 5 5s in the circles, and that 5 appears 5 times in the circles. And that's an example of how counting circles work. We also have German whispers, or as I like to call them, whisper 5 lines, where adjacent digits along a green line must differ by at least 5. So, for example, if this were, say, a 3, this would have to be an 8 or a 9, because those are the only digits which are 5 or more away from 3. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, for counting circles, I like counting how many circles there are, because then that tells us the total sum of the digits that must be in the circles, right? Because 1 must appear 1 time if it appears in a circle, 2 must appear twice if it must be in a circle, 3 appears 3 times, etc. And that means you can go from 1 through 9 total, which could give you a 45 of the number of circles in the puzzle. Max. Obviously, if it's less, you can remove numbers from the circles to add up to the amount of circles there are. So this is 1, 2, 3, 4, 5, 9, 13, 16, 20, 23, 26, 29. So we are missing 16 circles of the max. So that means the digits that are missing must add up to 16. We know in box 3 we have every digit but 3 of them are on the whisper 5 line, and the rest are in circles. So that means you are guaranteed a 5 in the circles. So 5 must be in a circle. How many different digits do we have? I think, well, we have 5 at least, but that's not really helpful. I guess it is somewhat helpful. That means you can't have 1, 2, 3, 4, 6 as the missing digits. Oh, one of them has to be high and one of them has to be low. Inside the circles. That's not helpful. That doesn't really tell us much. Never mind. Hmm. Okay. Interesting thing about column 8 is all of the digits are on whisper 5 lines except for the digits which are in circles in column 8. Same. Oh. Interesting. Same with the digits in column 3. So this must be 5 and a certain set of digits. It must be either low or high. We're not sure which. So we're going to make this green. Green. Maybe we'll make it orange. We'll make this orange and pink. So these are size orange and pink. Pink stands for 5. And the remaining digits, we're going to make those green. That means these are orange to match. Interesting. So, if the digits in these circles were all high, that would mean you have 5, 6, 7, 8, 9 guaranteed to be in circles. But that adds up to 35. So you would have 35 digits. So the orange cells cannot be high digits. They must be low digits. And the green cells have to be high digits. So this digit is in between next to one unique digit on the Whisper 5 line. This is next to 2. This is next to 2. So these have to be 7, 8, or 9 here. And we have 1 through 5 guaranteed to be in a circle, which means again, the other two digits. So there has to be at least two digits that are not in circles. And the total number of the digits of circles must be the total number that the digits add up to that are in circles. So we have 1 through 5 guaranteed. That's 15. We have 29, again, circles in total, right? 4, 8, 13, 16, 18, 21, 23, 25, 29. That means the digits in the circles have to be 1 through 5 and 6 and 8. Because there's no other combination of digits that can add up to 14 from 6 through 9. And we are guaranteed here these digits must be 1 through 5. So the digits in the circles have to be 1 through 5 and 6 and 8. Therefore, in one of these has to be a 5 because there's no other place for 5 in column 8. These are low. This is between two unique digits on a Whisper 5 line. So it has to be 1, 2, 3. This is 1, 2, 3, and this is 1, 2, 3. This is 6 through 9. Obviously, this can't be 6 or 8. We have a 1, 2, 3 triplet in column 2, which eliminates 1, 2, 3 in the rest of the column. So we have 4, 5, 6, and 8 guaranteed in column 2. So this must be 7 or 9, and this must be 7 or 9. This is a high digit, and this must be high, obviously. Okay. Let's see. We have these two must be opposite sets. Okay, all of this is predicated because we know on a Whisper 5 line or a German Whisper line, you'll always alternate between low digits and high digits. So, because 1 through 4, what digits can be next to it? 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can only be next to 9. So for a low digit, you'll always be next to a high digit. And because of the same logic looking at the other way, a high digit will always be next to a low digit on a Whisper 5 line. We know 6 is one of these two digits, and it's guaranteed to be next to a 1. So this cannot be 1 here. Do we have circles? No, we don't. Okay. Okay, so where is the 5 in column 8? It has to be one of these two digits. Where is the 5 in column 7? It's one of these three. Where's the 5 in box 9? It must be one of those two. So, okay. We have a guaranteed 1 in the circles in column 3. That means 1 can never appear in the rest of the circles. So we can remove the 1s available in the rest of the circles. We have a guaranteed 2, obviously. We have a guaranteed 4 here. We have a guaranteed 5 and a 6 and an 8. We have a guaranteed 5 here. We have a guaranteed 5 here. Okay. These digits are going to be opposite of each other. Same with these. So let's make this green, and we're going to make this medium. Green and medium. This is green and medium. How about these? This will make yellow and orange. So this is yellow, yellow, orange, yellow, orange. We know 8 cannot be in a circle in column 3. Therefore, it's guaranteed in every other column because it has to be in... Therefore, this has to be a 5-8 pair here. So this is a 5-8 pair because it has to be in a circle in every column but column 3 because it's not in column 3. Therefore, there must be 8 eights in circles. So that means every other column must contain 8 in a circle. So this is 5, and then this must also be 8. As a combination. So this is 5 and 8, this is 5 and 8. These two digits, there's one of each set. These two digits, this is the different set than that, which is this is the same set as that. It's a different set than that. So these are a different set. These are a different set. That means green has to have 4 cells in column 8. So 5 and 8 must be from the high digits, so the greens have to be low, which means the medium grays have to be high. We are guaranteed one of these digits is an 8, because if it's not, then that means 8 has to be outside of a circle in this box and outside of a circle in column 3, and that's not allowed. So that means 8, this must be 8 in some 8 as the high digit here, which means 6 cannot be the high digit here because we have 3 other high digits in this box. So 6 has to be on the Whisper 5 line, and 6 can only be next to one unique digit on the Whisper 5 line, so this must be 6 here, because that's only next to 1. These are next to 2 each. So 6 must be next to 1, which has to be next to 7 or 9, and 7 or 9 here. Well, the only digit which can be next to 7 or 9 out of these digits, because we already have a 1, it can't be 1, it has to be 2. So 2 is eliminated here. That means this is 3 or 4 here to be next to 7 or 9 here. We have a 7-9-7-9 pair now in row 1, so that eliminates 7-9 in the rest of the row. This 2 eliminates 2 here. Remaining digits in column 8 are 3, 4, 7, 9. Well, this digit is next to 2 unique digits on a Whisper 5 line. If this were 7, this could not be 3 or 4. So this can never be 7 here. If this were 7, this could never be 3 or 4 then either. 7 can only be next to 1 or 2 on a whispered 5 line, so therefore 7 cannot be here. That means one of these two is a 7 here. Which means this cannot be 9, because these are opposite sets. So this is guaranteed not to be a 9. 9 has to be with 3 or 4. This can't be 4 because it's next to 2 unique digits on a whisper 5 line. This can't be 4 because it's next to 2 unique digits on a whisper 5 line. So if this were 9, it would have to be a 1, 2, 3, or 4 here. If this is 3, that's 9, and this has to be 8. So those are the only possibilities for those cells. If this is 7, this has to be 1 and 2 here. If this is 3, this has to be an 8, 9 pair here. Okay. We're gonna make these... I guess medium and dark. Medium and dark. Okay. 6 is here, which eliminates 6 in the rest of the row. So 6 does not appear in a circle here and does not appear in a circle in column 3. There's one more column where 6 cannot be in a circle. Oh, and it has to be in box 9. So in box 9 and in box 3, along with column 3, 6 cannot appear in a circle. Oh, this has to be... Okay, what is the 8? So we're missing an 8 from a circle in column 3, which means there is, either in box 1, 2, 1, 4, or 7, the 8 is not in a circle. That means in box 9, there has to be an 8 in the circle. So that means this is an 8, which is a high. That means where's the 5 in this box, it has to be here. So that's 5, which means this is pink, so this cannot be pink here. That means this has to be 5 here and is pink. 8 cannot be outside the circle in box 8 because, again, it's outside the circle only in column 3, which only is only in box 1, 4, or 7. So this must be a low, which makes this a high. So this is a high digit, which makes this a low. So this is 3 or 4. This has to be 9. That's next to 1, 2, 3, or 4 here, which is next to a high digit here, which makes this low. So this is 8. If this were 3, this would have to be 8 and 9 as a pair here. So this cannot be 3. This is 7, which means the darks are highs and the mediums are lows. So this must be 1 and 2 next to the 7 on the whisper 5 line. We have to have a 6 on the whisper 5 line, and it must be here. So this is 6, this is 9. 9 can be next to 3 or 4 on the whisper 5 line. So this is a 3-4 pair, which eliminates 3 and 4 in the rest of the row. So this can't be 3 or 4. This can't be 3 or 4. We have a 1, 2, 3, 4 quadruplet in row 7. And this can't be 5, so this must be a 6-8 pair, which means it's next to 7 or 9. So these are all highs. The 6-8 pair eliminates 6-8 in the rest of the row. So this can't be 6-8. This can't be 6-8. So this is 4 or 5. We have a 7-9 pair here. We have a 1-2 pair here, which eliminates 1 and 2 in the rest of the row. Or sorry, box. Where is a 6, 8 in box 7? It has to be in these two cells because this can't be 6 or 8 because of the 6 or 8 in the row. And these can't be because of the way that it works out with the circles and the digits in this cell. So this has to be a 6, 8 pair, which forces this to be 3, 4, 5 here. So this is a high. This 6, 8 pair eliminates 6, 8 in the rest of the column. This 1, 2 pair eliminates 2 in the rest of the column. Or row, sorry. This 7 eliminates 7 here, so this is 9. This can't be 9, so this is 7. This 9 eliminates 9 here, so it's 7. None of the rest of column 3 can be 7. We have an 8, 9 pair now in column 3, which eliminates 8 and 9 in the rest of the column. So this must be not 8 or 9, it's 6, which can only be next to 1 on a whisper 5 line. So this 1 eliminates 1 here, so it's 2 and 1. So this is the one that's in a circle. 2 eliminates 2 here, so it's 3, which means this can't be 3, and these cannot be 3. This 5 eliminates 5 here. So where is the 5 in column 7? It has to be on a non-whisper 5 line, so this must be 5 here. So this cannot be 5 here or here. One of these is an 8, which eliminates 8 in the rest of column 9. And this can't be 5 either. Whereas the 8 in column 7, it has to be in the circle, so this is 8, which eliminates 8 in the rest of the row. Whereas the 8 in box 5, it must be one of these two digits here in the circles, so it cannot be here. Where's the 8 in box 2? Again, the 8 is missing from the box. Actually, we know now. The 8 is missing from a circle in box 4. So that means every other box must contain an 8. Well, it can't be here, so this must be 8 here, which eliminates 8 here, whereas the 8 in box 3, it has to be here. Whereas the 8 in box 1, it has to be here. 4 is missing an 8 from a circle. This 8 eliminates 8 here, so it's 6 and 8, which makes this 6. The 8, where's the 8 in box 8? It has to be here. So those are all done. Okay, 8's one of these two. That's fine. We have 6's all missing from circles, so now all the other 6's have to be in circles. We have the 6 already in box 1. In box 2, where is it? It has to be here. In box 3, we have a 6 outside a circle. That's the second one that we have. In box 4, it could be any of these two. That's fine. In box 5, it cannot be here or here, so it must be here. In box 6, it's one of these two circles. And box 7, we have it. Box 8, we have it. Box 9, we have the 6 outside the circle, so that's the third digit, which had to have their third box, which had to have 6 outside of a circle. Okay. This is high. This 5 eliminates 5 here and here. This 7 eliminates 7 here, so it's 9, which makes this 7. Oh, this had to be 9 anyways. This yellow cannot be 6, 7, 8, or 9, so it must be a low. So yellows have to be lows, oranges have to be highs. Okay. This can't be 6, 7, or 8, therefore it must be 9 as a high. This can't be 6, 8, or 9, so it's 7 as a high. Also, the remaining digits in column 4 must be remaining low or 5. So lower 5, lower 5. This digit can't be 6 or 7. It can't be 8. It must be 9 here, which makes this 7, which makes that 9. Yeah, this 9 had to be next to a 3 or 4, so that's fine. Remaining digits in row 2 have to be blue or 5, lower 5. So is row 1. Where is the 9 in row 3? It cannot be any of these cells because of the 9s in the boxes. Can't be any of these because this has to be low or 5. This is low. So this must be a 9 here, which means this is high. Where is 7 in column 1? Can't be here because it's 7 in the box. Can't be here because 7 in the box. This is 7's not in a circle, so it can't be here. 7 can't be here because it's 7 in the row. So 7 has to be here and is a high. We should have, I think we have all the, yes, this 9 eliminates 9 here. So this is 8, this is 9. That gives us all the 9s, and it should give us all the 8s. Except, yeah, this can't be 8 here because of 8 in the row, so this must be 8 here. And is a high. So I think we actually have all the 8s and 7s and 6 through 9s all sets, I think. 7, not completely. Okay. So we have, where is the 7 in box 6? Cannot be here or here or here or here. So it has to be here. So that's 7. And then we have 8 7s. We know where the last 7 has to be. It has to be here. So that means we should have all 7s. We should have all 6s now, too. 1, 2. We don't know which one of these is a 6. But we don't need coloring anymore. Because, well, it's fine. We'll just leave it here. This has to be low, so it's 1, 3, or 4. This is next to 2 9s. This cannot be 5 here, but this could be 2, 3, or 4. That's fine. This is next to 7 or 9, so it's 1 or 2. And that's it for that. Okay. Remaining digits in row 1. We have 1, 3, 4, 5. 1, 3, 4, 5, but 1 cannot appear here. So 1 has to be one of these 2 digits here. Okay, this 3 eliminates 3 in the box. Where's the 1 in box 4? Cannot be here, cannot be here. Why can't... Oh, 1 can no longer appear in a circle, so therefore this must be the 1 here. That eliminates 1 in the row. This has to be 2, 3, or 4 because it cannot be 6 or 5 or 7, 8, 9. 1 has to appear in non-circles. That's fine. Where's 1 in box 6 then? The only non-circle left that's not eliminated by 1s in rows and columns has to be here. So this is 1, which means this can't be 1. That's 2. Where is the 1 in row 4? It has to be here. So this is 1, which eliminates 1 here, which means where's 1 in row 1? It has to be here. So that's 1. Where's 1 in column 6? Cannot be here because of 1's in the boxes. Can't be here because it's filled out. Can't be here because of the 1, 2 pair in the row. So this must be a 1 here. And these are 3, 4, 5. This 2 eliminates 2 here. Where's a 2 then? In box 8. It can only be here. Not 5, 2. That eliminates 2 here. This can't be 2. This is 3, 4, 5. Cannot be 3 because of the 3 in the row. 2 eliminates 2 in the rest of the row. So this is 4, 5. We have a 4, 5, 6 triplet in box 4, which eliminates 4, 5, and 6 in the rest of the box. This can't be 4 or 5, so it must be 2. That's the other 2 that's in a circle. So where's the 2 in column 3? It must be here. That means we cannot have 2 in any other circle, so this can't be 2. Where is the 2 then in box 6? It has to be here. So this is 2 here, which eliminates 2 here, so it's 1 and 2. Where are all the ones? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have all the ones. Twos, we have 1, 2, 3, 4, 5, 6, 7, 8. We know where the last 2 has to be then. It has to be here. So this cannot be 2. We have a 3, 4, 3, 4 pair in column 5, which eliminates 3 and 4 in the rest of the column. So this must be 5 here, which means this cannot be 5 here. This can't be 5. So there's no pink here. This is pink and not blue. This is not pink. This can't be pink. This can't be pink. Any of these are pink. Okay, we have in column 9 a 3, 4, 6 triplet all in circles. So that's a guaranteed 3 in a circle there. In column 3, of course, we have the 3 guaranteed in a circle. We need another 3 that is in a circle. So either any of these work. How many 5s do we have in circles? We have 1, 2, and 2 not in circles. That leaves 3 remaining in circles and 2 not in circles. We have 1 guaranteed here, so that means 2 guaranteed in circles. We have 1 here, so that's 2 more guaranteed in circles. So we have 1 more 5 that's guaranteed to be in a circle. And so it's either here or here. We're not sure which. If this is a 5, this can't be 5. If this is a 5, this can't be 5. So either way, this can't be 5. We also knew that because this was one of these two had to be 5 because it couldn't be 5 here. So one of these two is a 5. We know one of these two is a 5 also. Guaranteed to be in a circle. So that means we cannot have a 5 anywhere else in those rows. So this cannot be 5 here. We have a 3, 4, 3, 4 pair now in column 1, which eliminates 3 and 4 in the rest of the column. So this must be 5 here, which means this can't be 5 here. So this is not pink. This is pink. We have 3 guaranteed. Well, that doesn't help much. 5 is not in a circle here. It's in one of these. It's guaranteed in one of these. That's 2. It's guaranteed in one of those 2. So that's all the 5s accounted for. 4, we're guaranteed one of them in this circle, one of them in these 3, one of them in these 3. That means, where can the 4 be in the last part? It could be here, or it could be here. We just knew this couldn't be 5, so that wasn't helpful for that. But 4 could actually be here and then here, or one of these two, right? Okay. What about rows? In row 1, we have a 5 not in a circle. In row 2, we have a 5 not in a circle. Row 3 has a 5 in a circle. Row 4 has a 5 in a circle, so that's 2. Row 5 could have or could not. Row 6 has a 5 in a circle. Row 7 has a 5 outside a circle. Row 8 has a 5 in a circle, so that's not helpful. Okay. Um. hmm. Uh, okay, let's remove the coloring because it's not helpful now. And let's use the coloring for something else. Let's do it for 3-4 pairs. We're going to make this green and this red for the 3-4 pairs. That makes this a red here, which makes this a green. This green makes this a red. This red makes this a green, so this is red, which makes this green. So red is one of these two. Red has to be one of these three. Green is one of those two. Green could be any of these four. Okay. So red cannot be here. Red is one of these two. Oh, red's here, so this can't be red. This is green. Green cannot be either of these here, so this must be a green here. So since this is green, this cannot be green. Therefore, green is over here, which means this can't be green, which means green's here. So then green cannot be either of these. Green has to be this one. So it must be the 4. So green has to be 4. That means red is 3, so red cannot be either of these. So green is 4, red is 3. This 4 eliminates 4 here, so it's 5. This has to be 3. This can't be 3 or 4, so it's 6. This can't be 4 or 6, so it's 3. This 4 eliminates 4 here, so it's 6. This can't be 4 or 6, so it's 5. This 4 eliminates 4 here, so it's 3. This can't be 3 or 4, so it's 5. This can't be 3 or 4, so that's 5. And that should be all the digits. How many ones are in circles? Okay, so 6 is 1, 7. So all the German whisper or the whisper 5 loops are working. 1, there's only 1 in a circle. 2, there should be 2. We have 1 here and 1 here. 3 should have 3. 1 here, and 1 here. 4, there should be 4. 1, 2, 3, and 4. 5, there should be 5. 1, 2, 3, 4, 5. 6, there has to be 6. 1, 2, 3, 4, 5, and 6. 8, there has to be 8. There's only one 8 that's outside circled, and everything else is kosher. Anyways, I hope you enjoyed this solve today, and I'll see you next time on Frank Puzzles. Take care.